Hello everybody. Today I, Shristi Jamdade, along with my group members Rituja, Patil, Neha, Shinde and Sudarshan Rathod will be presenting on topic partial discharge measurement before you. What is partial discharge? Partial discharge is an electric discharge that does not completely bridge the gap between two electrodes. PD happens all the time in power system but usually occurs in components that can withstand it, such as switchgear. You may be aware of PD activity near you, that buzz you hear from medium or high voltage substation equipment or overhead power lines. Modern cables and cable accessories cannot withstand partial discharge. PD can slowly erode the insulating material until failure. The below two diagrams explain you what is partial discharge within the insulating system and partial discharge but surface partial discharge. Moving further, what are the different reasons for partial discharge? Cable systems are designed to withstand a significant amount of electrical stress. Anything that causes a localized increase in that stress can lead to PD activity, such as voids in the insulation, damage to the cable from the backfill, moisture infiltration, enhancing an existing localized stressor that is water trees, insufficient grease used during accessory installation, and improper cutback during accessory installation. What are different types of partial discharge? Partial discharge can be classified into three main types. That is, internal partial discharge, which occurs inside the insulation. Second one is surface partial discharge, that is, tracking across the insulation. And third one is corona partial discharge from a short electrode into gas. The below table explains you in a more efficient way. Partial discharge, which is again classified into two main categories, that is external and internal. External is further divided into corona and surface discharge. Internal is classified into three categories, that is cavity discharge, stream and tracking. What are the factors affecting discharge detection? The very first is the applied voltage, second is dielectric constant of the insulation material, and third is the size of the void. Now we will study the various methods, that is PD measurements by state detection method. The below is a circuit diagram of the following. So what is state detection method? The PD current is made to flow through a known impedance known as measuring impedance. This creates voltage drop across it. This voltage drop is proportional to current. Hence the voltage waveform can be analyzed on the CRO. A band pass amplifier is connected across the ZL. This amplifier amplifies the PD current pulse, which can be observed and stored at the CRO. Thus, analysis is possible. Next, moving to PD measuring system within the PD test circuit. So below are the two diagrams. First, A1 is coupling device in series with the coupling capacitor, and the second one shows you coupling device in series with a test object specimen. So what is it actually? This includes a measuring circuit that is integrated into a test circuit. This can be used for detection of repeatedly occurring PD. The external, the external noise is eliminated in this circuit. As shown in the figure A, CD is in series with the coupling capacitor and CD is at grounded potential. In figure B, that is the second one, the below one, the CD is in series with the test object CA. What are the sources and how it can be reduced, the disturbance can be reduced? So what are the sources? The sources are primarily two, that is the first one is partial discharge, the second one is presence of harmonic. Now how can we reduce the disturbances? First, we can reduce it by filtering method, second by screening method, and third by shielding method. So what is the calibration of PD detectors? How are they calibrated? So the measuring instrument is calibrated by injecting a pulse having a charge of a known magnitude. The charge is injected using a square wave generator. Suppose a charge injected is Qt at a voltage pulse of Vt through the capacitor Ca. Therefore, Qt is equals to Vt into Ca. A small time rise of 60 and second is specified for this voltage. So this is the circuit diagram of the following, that is the calibration of the PD detectors. As you can see, so moving further, digital PD instrument. So what is digital PD instrument? This particular figure is the block diagram of a typical digital PD analyzer. It consists of a pulse height detection circuit, phase detector circuit, interface unit of a computer. As we can see, there is amplifiers, that is polarity detectors and absolute value detection, threshold and peak detection, AC, ADC, status detectors, control circuits, and RAM. Also in this following block diagram. The pulse height detection circuit detects the PD pulse, and sampling circuit converts it into a digital form. The phase detector detects the zero crossing instant. The polarity of the pulse is detected by the polarity detector circuit. The interface unit synchronizes the pulse height and the phase data required for computer storage. The computer provides effective and user-friendly interface. Now moving forward, we can understand partial discharge in a very effective way using animation.
Partial discharge (PD) essentially a smart recursive based in high voltage electrical stimulation. It's called a partial discharge because discharge only partially bridges the gap between the conductors. Discharge may be a gas-filled void in a solid insulating material, in a bubble in a liquid insulator, or around an electrode in gas. In high voltage cable systems, PD is commonly found in joint accessories where a defect or void exists. These are caused by incorrect installation or long-term degradation of the equipment. Switchgear, cracks and voids in insulating materials and components causes PD internally. Contamination, outer surfaces, or incorrect installation of insulators, bushings, terminations will cause surface PD. Partial discharge is generally accepted as the predominant cause of degradation and eventual failure of electrical insulation. According to research, 80% of high voltage failures occur due to asset damage caused by PD activity. PD activity can be monitored on service equipment to reduce these failures.
So this slide shows what are the work distribution from our team members. Rituja, Patil has contribution in making PPT and gathering information. I, Shristi Jamdade, have carried out PPT presentation and explanation. Neha Shinde has contribution in making PPT. Sudarshan Rathod has helped us on animation video. So these are the questions which you will be able to answer when you watch our presentation. So the questions are: what do you mean by partial discharge? What are the reasons responsible for partial discharge? What are different type of partial discharge? What are the factors affecting discharge detection? What are the different methods to measure partial discharge? What are different sources of partial discharge and how they can be reduced? Thank you.